Well, Yellowstone is one of the country's most visited national parks, but social media rumors about the Yellowstone volcano.
A violent blast shook Yellowstone National Park. Then the ground cracked open and scientists shut everything down. The explosion came without warning. No earthquakes, no smoke, just a muffled boom from deep underground. What they discovered beneath the surface stunned experts and sent shockwaves through the scientific community. This wasn't just another geyser eruption. Something had changed. Something Yellowstone has been hiding for thousands of years. Could two of America's most dangerous volcanoes be stirring at the same time? And if they are, what does that mean for the millions who live in their shadows? Let's find out. For months now, attention has been building in the Pacific Northwest. Beneath Mount St. Helens, seismographs began detecting an unusual clustering of quakes. At first they seemed small, barely noticeable without sensitive equipment. But then came the numbers. More than 400 individual tremors rattled the mountain's northern flank between January and March alone. That location is no coincidence. It is the very zone that catastrophically collapsed during the infamous 1980 eruption, an event that killed 57 people, erased entire forests, and left a permanent scar across the landscape. Now, 4 decades later, something is stirring in the same place. Aerial and satellite images have confirmed what scientists feared. The ground around the volcano is rising, subtle at first, but measurable. A swelling measured in centimeters, growing steadily week after week. To the untrained eye, it looks like nothing. But to volcanologists, this is a familiar and ominous pattern. In 1980, the mountain bulged outward before it exploded with devastating force. Today, a similar bulge seems to be taking shape again. And swelling ground usually means one thing. Magma is pushing upward, displacing rock and soil as it seeks release. But tremors and uplift are not the only signs. Gases have begun pouring from the vents and fumaroles with disturbing changes. Sulfur dioxide, carbon dioxide, and hydrogen sulfide have spiked, tripling in concentration within weeks. Such gases are fingerprints of rising magma, released as molten rock forces its way toward the surface. This chemical warning has been enough to put monitoring stations on high alert. But while scientists watch their instruments, the wildlife is already responding. Birds that once filled the air with sound have gone strangely silent. Elk herds that grazed peacefully near the mountain's base are moving away in large numbers. Small mammals, normally unnoticed, are suddenly restless and disoriented. Animals have long been known to sense subtle shifts in pressure or magnetic fields long before humans notice. Their behavior here is speaking volumes. Locals have even reported hearing a strange, low-frequency hum, steady, deep, and unsettling. At first dismissed as imagination, scientists soon confirmed the phenomenon. Instruments at the Cascades Volcano Observatory detected harmonic tremors, continuous vibrations linked to magma moving through fractures underground. The Earth itself seemed to be humming a warning. Alone, these signals would be troubling. Together, they paint a picture of pressure building deep below Mount St. Helens. Yet what has alarmed scientists even more is that this activity may not be confined to Washington state. Nearly 560 miles to the east, beneath Yellowstone National Park, signs of unrest are emerging too. Yellowstone has always held a place of uneasy fascination. It sits atop one of the largest volcanic systems in the world, a supervolcano fueled by a deep mantle plume. In recent months, geysers and hot springs have grown unusually active. At Norris Geyser Basin, eruptions have become more frequent and unpredictable. Steamboat Geyser, the tallest in the world, has entered one of its most active phases on record. These might seem like tourist spectacles, but to scientists, they are data points in a bigger picture. GPS monitoring stations have picked up measurable uplift within Yellowstone's caldera. The ground is slowly rising, suggesting pressure from below. Seismic arrays beneath Yellowstone Lake have detected long-period earthquakes, deep, low-frequency rumbles, often tied to the movement of magma or superheated water. The timing of this activity, aligning with Mount St. Helens' growing restlessness, has sparked a troubling question. Could these two volcanoes be connected? At first glance, the idea seems impossible. They are separated by hundreds of miles across states and mountain ranges, but the Earth's crust is not neatly divided. It is fractured, crisscrossed by faults and stress lines that stretch vast distances. A major shift in one system can ripple through others. This concept, known as the cascade effect, is not just a theory. History has shown it before. When Mount Pinatubo erupted in 1991, nearby volcanoes showed unusual seismic changes. In Iceland, eruptions have destabilized neighboring systems, triggering further activity. Stress and pressure are not bound by geography the way humans imagine. Now, computer simulations are exploring the possibility of a similar cascade between Mount St. Helens and Yellowstone. Feeding in seismic data, GPS deformation records, and historical eruption patterns, the models suggest that even minor disturbances in one volcano could alter the stability of the other. The probability of a direct trigger remains low, but not zero. And with two restless systems showing signs at once, the question has become unavoidable. Are we seeing isolated events or the beginning of a chain reaction? Satellite-based radar has added fuel to the concern. Interferometric images show subtle but widespread surface deformations within Yellowstone. These uplifts are not dramatic bulges, but they echo patterns observed before past hydrothermal and volcanic events. Combined with the gas spikes and tremor swarms at Mount St. Helens, the picture grows more complex. Could the Earth be whispering about a deeper link between these giants? The very phrase Yellowstone eruption carries weight. For decades, it has captured imaginations with visions of ash clouds blotting out the sun. Scientists emphasize that a full-scale super-eruption remains extremely unlikely, but even smaller events could carry devastating consequences. A moderate eruption at Yellowstone could blanket vast areas with ash, contaminating water supplies, crippling agriculture, and halting air travel across half the country. At Mount St. Helens, the dangers are different but no less severe. Lahars, fast-moving volcanic mudflows, could race down valleys and destroy communities in minutes. Yet what unsettles observers most is the timing. Two volcanoes, far apart but stirring together, each showing signs of pressure, uplift, and gas release. Silence on the surface, but turmoil beneath. For volcanologists, silence is not comfort. It is the breath before the voice. And history has taught us that these voices can be sudden and violent. In 1980, the bulge at Mount St. Helens grew steadily for weeks before the mountain finally gave way in a catastrophic lateral blast. In Yellowstone, uplift cycles have sometimes lasted years, followed by sudden releases of steam and ash that reshape the land. Each cycle is part of the Earth's living system. The challenge is knowing which cycle ends quietly and which ends in disaster. Modern science has given us tools our predecessors never had. Seismometers, GPS trackers, gas sensors, and satellites form a constant web of surveillance. Subtle vibrations can be detected instantly. Even shifts of a few millimeters in the ground are now visible from orbit. Thermal imaging reveals hidden hotspots. Gas sensors sniff out changes invisible to human senses. These instruments work together to give scientists a clearer view of the invisible forces moving beneath the crust. And yet, despite all this technology, the Earth remains unpredictable. Models can suggest probabilities but not certainties. Harmonic tremors might fade without an eruption. A swelling ground might deflate harmlessly. Or they might not. For scientists, every sign is a clue, every tremor a data point in a story the Earth is writing. Public safety now depends on listening to that story. Communities near Mount St. Helens have evacuation routes mapped. Lahar detection systems monitor valleys for the vibrations of mudflows. Emergency drills remind residents of what to do when alarms sound. In Yellowstone, education campaigns focus on ash hazards, how to prepare homes, protect water, and endure disruptions. Authorities know they cannot stop an eruption, but they can prepare for one. Still, the sheer scale of these volcanoes leaves little room for comfort. Even a smaller eruption at Yellowstone could cripple transportation, choke crops, and cost billions in damages. A full super eruption would rewrite history, dimming the sun for years and plunging the world into volcanic winter. Agriculture would collapse, food shortages would spread, and ecosystems would unravel. The probability may be small, but the stakes could not be higher. As scientists watch, they remind us that the Earth is alive. Every quake, every gas spike, every subtle uplift is a reminder of forces beneath our feet. Forces that have shaped continents, destroyed civilizations, and built new landscapes. Forces that do not bend to human schedules. So for now, tourists still walk Yellowstone's trails, marvel at geysers, and hike the slopes of Mount St. Helens. Life goes on above, but below magma shifts, gases rise, and stress builds. The Earth is whispering, and we must decide whether to listen. Yellowstone and Mount St. Helens remain quiet for now, but silence in volcanic terms is never safety. Sometimes it is the pause before the roar. Scientists are watching, measuring, and warning, but when the Earth finally speaks, will we be well prepared to handle it? If you like this video, you will like this video as well.